Welcome to the 8th video in the series called Video Standards, Signals, Formats, and Interfaces. Besides the number of pixels per active line, the number of active lines in the picture, and the number of picture frames per second, there are subtle issues such as interlacing, the total number of samples per full line, and the full number of lines in the SDI signal. Last but not least is the method of packing all these data samples, and can we put something useful in the idle planking intervals. Today you will learn more about the scanning, sampling, and packing of digital video image samples. The BT601, or CCIR Recommendation 601, standard established for the first time a unified global digital component format, which shared the sampling frequency with both widely used scanning standards of the world, 625I25 and 525I29.97. In accordance with the BT601 standard, the sampling rate 13.5 MHz and the digital active line 720/360 pixel counts are common for 50 Hz and 60 Hz countries. This commonality made possible the fast global spreading of digital component equipment and the analog to digital transition. All following video standards, SDI, HD, UHD, MPEG, etc., are based on this concept. They are only the smart siblings of the great mother born in 1982, Rec 601. This diagram illustrates, in the example of the digital composite PAL video format, the variety of analog and digital, component and composite formats related to a single 625I25 standard. Note that digitization of analog composite signals requires a higher sampling rate than digitization of the analog component content. It's very important to locate correctly the two digital active picture areas, which will be later combined into one deinterlaced active frame and scaled to the desired digital component format, such as 720 by 576 P25 or 720 by 576 P50. Compatibility with the interlaced video materials and existing infrastructure requires 25 and 29.97 FPS operation. Compatibility with the film world, which tends to shoot at 24 frames per second, requires 23.976 and 24 frames per second. There are two main families of HD and sub-HD scanning standards, 1080 and 720. Not all combinations of scanning standard and frame rate are valid. For example, an interlaced 24 FPS standard does not exist. The 50 Hz countries use only 24, 25, and 50 Hz frame rates. In 60 Hz countries, frame rates come in two flavors: an integer number of frames per second, or 1 part per thousand less than this. The sampling rate is also adjusted correspondingly. Sub-HD and HD, except the high frame rates 1080p 50p and 1080p 60p, share the same sampling rate, 74.25 MHz. The UHD case is more complicated, and we'll cover that later. Using the same sampling rate for several quite different scanning standards is possible only because the samples are packed in accordance with the common image format sampling structure. Common image format numbers make sense only with application to the digitization of analog HD signals and/or real-time transfer of digital data over the physical interface, meaning SDI. For file-based operations, only active image data are relevant, and sampling rate value has no meaning. RGB and Y channels spatial sampling grids are always uniform, but the horizontal and/or vertical sampling rates of U and V channels are often reduced to save bandwidth and/or storage capacity. The reduction of U and V channels spatial resolution is possible because it is less noticeable than the reduction of RGB or Y resolution. Therefore, we have now 444, 422, 411, and even 420 spatial YUV sampling structures. Most component production equipment uses 444 or 422 sampling, but in distribution of compressed streams, the most used format is 420. There are two major groups of formats used to arrange RGB YUV samples. Interleaved, that is packed formats, are based on the pixel sequential multiplex of color component, or channel, samples. Planar formats are based on the sequential storage or transmission of three color separated frames, also known as color planes. VideoQ's VQB analysis software supports all the practically used RGB and YUV pixel formats, interleaved and planar. This video was prepared for you by a team of experts. Produced and narrated by Josef Marc, a member of SMPTE's HDR committee. Written by Dr. Victor Steinberg, co-founder and president of VideoQ, technical awards winner and author of the Video Standards book. Conceived by Roderick Snell, co-founder of Snell & Wilcox and winner of several technical Emmys and Queen's Awards. Technical consulting by Maxim Levkov, author of the Video Encoding Cookbook. This video series is brought to you by VideoQ, and you can download these slides and this video from VideoQ.com. VideoQ makes products and services for all sorts of video and audio processing and quality assurance. Based in Silicon Valley with software developers and distributors in several countries. Thank you for watching.